All right.
Good morning, y'all. We are the Marine Educators from the Marine Education Center. My name is Gaelyn.
I'm Raelly.
I'm Lacy. And we are here to give y'all a quick briefing about our East Beach activity. So we have a few tools here that we use to teach about the coastal environment here at East Beach. And we actually have all of our kids use these tools themselves after we teach them what to do with them. So this first tool we have right here is called a Seine Net. And this Seine Net, you can roll it out for me, has two wooden poles on the side of it, and then, that's good right there, it's got floats at the top, right here. So these floats are going to keep the net upright in the water. So it's kind of like a screen. So you're just going to walk with the net, and this is going to stay vertical in the water column, and it's going to catch lots and lots of fish. So it samples the water, the full depth of the water from where you're at. These sinkers down here at the bottom are going to help to hold the net taut like this. And that is going to prevent fish from swimming underneath the net, and the floats will prevent fish from swimming over the top of the net. So how this works is you have people on either side. Usually when we have kids, we have about 3 kids on either side. But since these guys are a little bit taller and stronger, we'll usually just have 2 people. And it can get kind of tiring because what you do is you have your poles and you set them at a 45-degree angle. So just like that. And after you walk and you wade out into the water, usually about waist deep, you put your poles on a 45-degree angle and then you walk forward. So the goal here is to keep your net spread open really wide and to not let it close in on itself. So if these 2 people start to close and get closer together, your net isn't open and it's not catching the fish. So they have to make sure that they are spread out far enough to catch your fish, and they have to keep their pole kind of almost digging into the ground in order to do that. So whenever you're seine netting, it can be really difficult depending on the wind and the tide and as well as the currents, because all of that moving water and all of those elements can affect how tiring it is for you to pull that net through the water. So usually after you seine, you'll count up your sample, you'll look at all of your different species, and then we teach the kids about each fish that we've caught, and then we throw them back. So it's a catch and release kind of system. And so after you seine one strip of water, you can walk out to a different spot and then seine another sample of water as well to make sure that you are catching stuff from different locations. And after you scare away all the fish in that one spot, you can move on to a new spot, probably where they went to hide from the last place. Our other sampling devices we have, this is a yabby pump. I'll have to go ahead and put this thing down. And the yabby pump samples the sediment, and it's sampling for invertebrates. So what we do here is you put the yabby pump into the sand at a 45-degree angle, you pull this lever up, and then you cup your hand underneath. So I'm gonna go over there, right there, and try. So with the yabby pumps, yabby, actually the word yabby is a type of invertebrate called a ghost shrimp or a yabby. It has 2 names. And they will burrow into the sand. They kind of make little tunnels. So you can catch yabbies, you can also catch different types of worms, like bloodworms, different polychaete worms. You can also catch clams. So clams are going to be 2-shelled organisms, or bivalves, so they kind of open and close like that. And they have what's called a muscular foot inside of them, so it's basically like a giant tongue that comes out, and they dig into the sand with that. So after you use the yabby pump in this spot here, you dump it into the sieve, and then we usually have about 2 kids on the sieve. This is the sieve here. It's kind of like a screen with PVC pipe that keeps it afloat, and it's got this wooden walls around it. So 2 people hold either side of the sieve, they put it in the water and then shift it out like this, and the sand is then washed away in the water and all of your organisms stay inside the screen. So after you sample, you can actually look at all your different things. The tide is very, very low right now, so this is not as ideal to do. But as you can see, we've lost our sand and we've kept a bunch of little rocks and things like that. A lot of our invertebrates are going to be farther down since it's going to be colder right now, and since the tide is so low. So, y'all would like to go out and try to gather some organisms to look at. Okay. Follow me. So while they go out to pull our Seine Net, I'm going to talk to you a little bit more about East Beach, where we're located, and what's unique about our Mississippi Beach coast. So right now we are in Ocean Springs, Mississippi, and Ocean Springs is going to be next to Biloxi. So usually when it's not super foggy, you can see the bridge that connects the two cities right there. So Ocean Springs is over here and then Biloxi's over there. And the Mississippi Ocean Springs, or the Ocean Springs location, is going to be close to the Mississippi Sound. So the Mississippi Sound is going to be a body of water that is between the Barrier Islands and the coastline. So if this is the Mississippi Gulf Coast right here, you have your Barrier Islands here, and the Sound is going to be all of the water in between that. So it's called a sound because it's going to be a very slow moving body of water. It's not going to have a lot of waves, and it's not going to have very strong currents that are moving that water constantly. So this is going to be a safe place for fish to come up and lay their eggs. It's going to serve as an estuary, which is like a nursery ground. So fish are going to come up and they're going to lay their eggs, and then they're either going to go back to their river systems, like up inland further, and then or they will go back to their ocean systems beyond south of the islands. So these Mississippi Sound and estuary environments are going to be super, super important for the populations of our commercial fisheries, for our local economy, and also just for the biodiversity of our ocean environments. So right now we are on East Beach, which is going to be a man-made beach. So most of the beaches in Mississippi are going to be man-made, they're not naturally made. So I believe Mississippi's coastline is about, or beach is 26 miles of man-made beach. And so that means this sand is not being deposited here from those currents. So like I said, usually on ocean bodies of water like the California coast or the East Coast, those are going to be beaches that are made from naturally moving currents from the ocean. So that moving water is going to be taking sand from the bottom of the ocean and depositing it to that coastline. But here, since we don't have those big currents coming from our Mississippi Sound, we have to make our beaches ourselves. And so what we do is we use a dredging system to pump sand out from the Mississippi Sound, and we take it out of the bottom and we put it up onto the coastline. And so it's kind of a multi-purpose situation. So we gain a beach from that, so we are able to enjoy the beach. And then we are also creating channels for ships to come through and deliver different goods or just different things like that, like the bananas in Gulfport. So Gulfport, Mississippi has pretty much any banana in the United States has come through the port of Gulfport because they're all coming from South America. And so there's like lots of chiquita and dole industries and things like that that are relying on that port to bring in bananas. So if we didn't have channels that had deep enough water for those giant barges and boats and ships to come through, then we wouldn't be able to have goods like bananas, right? You can see out there, they are pulling our Seine Net so diligently. I hope they are catching things. Any questions popping up on there?
Not so far. So what types of things do you normally see whenever you do this?
So we usually catch things like I said, how we are in an estuarine environment, we usually catch small fish, so they're not going to be full grown. They won't be in their adult stages yet, so we usually catch things like croaker, menhaden or pogies, Sometimes we catch little flounder, super cute little southern flounders. We catch black cheek tonguefish, white shrimp, brown shrimp, and every now and then we'll catch something like a little puffer fish. We'll have like least puffers. Really just depends on the day, depends on the water. And
looks like Riley's got something.
yeah, I'm not sure what Raelly has. So after you pull the seine net, what you do is the two people on either side take hold of that pole, and they have to lift it and lower it into the water to clean off the net because it can have lots and lots of dirt on it. Also, whenever you want to examine your specimen from the top after you lay the net onto the ground, you never want to step on the net because then you get holes in it. Okay, so looks like we have
a little hermit crab.
a hermit crab here. So hermit crabs are known as hermits because they actually do not make their shells, they find their shells. So they will either occupy a shell from an organism that died, so like a snail, that's the shell from a moon snail right there. And so he probably either just took this shell after that moon snail died, or he went in and ate the moon snail and then stole its home, basically. So that's why they're called hermits. Other organisms like clams, mussels and things, they actually create their shells. So they layer basically lots of minerals and calcium from the ocean and from the sand. They layer that over and over and over again, and that's what creates their shells. But our hermit crabs don't do that. This guy looks like a... We have green striped hermit crabs and I believe white striped hermit crabs. I think this one is I think this one's white. It looks like a white one to me. But yeah, so hermit crabs, they can come out of their shell, and then as they grow, they can pretty much just grow as big as whatever shell they're living in. So once they get too big for their shell, they just go find another one. So if you ever have a hermit crab as a pet, make sure you have lots and lots of shells inside there for them to switch out whenever they need to, which would be a really cool thing to watch. We should do a time lapse of that.
Oh yeah.
Super cool.
We have one comment from Kathy. She says, watching with a sick kid home from school. Love this. Thank you.
Aww.
Thank you,
I
Kathy.
hope you feel better. It's no fun to be sick, but it's always fun to miss school.
So is there any other part of this activity?
There's dip netting, which is pretty standard. I used to do this as a kid all the time on our boat launch. So it works just like a butterfly net, except in water. But the faster you are, the better, because sometimes those minnows can be super quick. So we usually come up into this inlet right here to do dip netting. Since the tide's kind of low, we have a huge sandbar in our inlet. But we usually catch different types of minnows, so like anchovies, silver sides, killifish, those kinds of things. And sometimes we catch lots of blue crabs with these guys. So the blue crabs like to be kind of in those stiller, shallower waters, and so they like to bury themselves in the sand, and they're very, very quick. So our kids like to take the dip nets and chase after the blue crabs and scoop them up. I wonder if there's any over there. Sure. I don't know what their preferred environment even is.
Probably some of those.
Oh yeah.
If you look at the sand right here, you can tell like the designs and all the patterns here. All of that is from the different currents and stuff in the water, so you can tell a lot about what's happening with the water and the tides just from looking at the dirt. And all the dirt, so the sand will change daily. So different layers of sand will be deposited, and then you can kind of look at chunks of sand. At Ship Island, a lot of times there'll be black sand, and then there's white sand, and then black sand, and it's just layered, and so you can tell what's been happening with the wind and how that sand's been moving over time. Also, if you go up into the marsh grass, you can usually catch lots of grass shrimp. So there's lots of different species of grass shrimp. but the really only way to tell them apart is by looking at their rostrum, which is going to be kind of like a horn on top of their heads. It's got grooves on it, so you kind of have to count the grooves to figure out which type of grass shrimp you actually have. I don't see it.
I think it's a molt. I don't see any inside.
Oh yeah, look at that. That is a molt. Cool. Okay, so this guy was growing, so he molted. Basically, he just got rid of his outer shell, his exoskeleton, so that he could grow to be bigger. I'm saying he. This actually, is this a female or a male?
That is a female.
It's a juvenile female. Yeah, so you can usually tell from looking at this arrow on their abdomen. So the females will have a dome shape. It'll be a wider arrow like this, and the males will have a skinnier shape. It can be kind of difficult to tell when they're small because it hasn't fully developed yet. But basically on the females, this part will house all of the eggs. So like a sponge, they will have millions and millions of eggs. It looks like a sponge. They're little tiny, tiny orange eggs, and they hold them on their abdomen, and then they release them. And the currents will take those eggs and deposit them different places, and so that's how they can spread their genes in different spots. So obviously not all millions of them survive, right? So it depends on your organism, because they know that most of them will not make it, so that's why they have so many of them, because they're trying to keep 1% of their population alive. That goes for all species, all organisms. So things that are more guaranteed to survive their younger years are going to have less offspring. So like a whale, right? A whale is going to lay. A whale is going to birth like one calf, and that calf is more than likely to survive, so they don't have to have a million of them. Whereas things like blue crabs, everything is going to eat those little tiny blue crabs, and so they have to have lots and lots of them so that they can keep that 1%. So they're named blue crabs for their color. This is the carapace right here, so the top of their shell is called the carapace. The bottom is called the abdomen, so that's right there. Ooh, I just made it really muddy. And these guys have an appendage behind them called a swimmerette, and it's kind of like a little paddle. So those little paddles are what helps them to swim into the water column. A lot of crabs can only just crawl and walk side to side on the sand, but these guys can actually swim up into the water. So they're known as beautiful swimmers, and their scientific name is Latin for that term, beautiful swimmer, which I can't remember what it is, so. But that's what it means.
Okay.
So,
Do you want to do like one more thing, see what happens?
yeah, go for it. Also, there might be an alligator over there in that bayou. Not right now, but there has been sightings. A lot of these little tiny holes are going to be from different invertebrates. These little burrows and things, they make homes with the sand. This tide line right here, you can see where the water's been. There is a term for this, can't remember what it's called.
Jessie wants us to know that she is watching.
Wow. Hey, Jessie. Hope your test went great today. This hermit crab has not moved. Put put him next to his kin. The other crab. Maybe if I put water in my hand, he'll come out. So Raelly and Lacy went out to try to pull the seine one more time to see if we catch anything. We're hoping for some fish. We want fish. We want fish.
What's one of the most interesting things you've ever seen them pull up when you do this?
It really depends on the day. That's probably the most interesting thing, is that there will just be one random day where you catch a whole bunch of different things. So sometimes with our yabby pumps we'll catch like little tiny eels, which is kind of weird. You wouldn't think you would catch that in the sand because they don't necessarily burrow, but some of them I guess do. So we've caught those with our yabby pumps, but the seines, we sometimes will see pipefish, which are going to be similar to a seahorse in appearance. Like their face, their heads kind of look like a seahorse, but they don't latch their tails the same way that seahorses do, and they don't have that big belly. So we'll see pipefish, toadfish every now and then. I believe those are venomous, but that's why we have degrees, because we know what the kids should not touch and what they should touch. We'll see lots of catfish, little ones, and so if we catch those, we just throw them back. And what else have we got? I haven't taught this in a long time, so I'm not sure.
And this lesson is available with our Coastal Science Camp option, right?
Yes. So this is with Coastal Science Camps. And so what we usually do is we usually walk the kids down the beach. We talk a little bit about the marsh grass that we have, and then we come out and we do these 3 lessons, or these 3 activities. So we can actually talk about the marsh grass since we're here. The marsh grass is going to be super important for the entire coastline. So the whole Mississippi Gulf Coast has to be protected by these marsh grasses for a few different reasons. So they protect us from hurricanes. We all know we get huge hurricanes down here. And so the marsh grasses are going to serve as like a buffer. So they're actually going to weaken that hurricane before it makes landfall and hits us, like civilized locations. That's also what the barrier islands are going to be doing. So the barrier islands are going to be absorbing that hit first. And so hurricanes need warm water in order to be strong and powerful, so they hit those barrier islands and they kind of dissipate. They break up a little bit and get weaker, and that eye wall kind of starts to weaken. So after that happens, they will come up and make landfall in the Mississippi area. So our marsh grasses are going to weaken those storms a lot and prevent them from being as damaging to our regions, but they also are going to be absorbing a lot of that flooding. So when those storm surges come up, the dirt and the grass are going to absorb a lot of that water, and so the flooding is going to be less extreme in our homes. And while they're absorbing water, they're also going to be filtering the water, so that marsh grass is going to be taking out different chemicals that are naturally present in the water, but it's actually going to be absorbing that and kind of cleansing the water a little bit. So we have 2 main types of marsh grass down here. We have smooth cordgrass and black needle rush. So the smooth cordgrass is usually going to be in front of the black needle rush because it likes water more. So it usually just hangs out in front, closer to the water. That way in high tide and in low tide, it's going to be in the water. But black needle rush doesn't like water as much, so it's going to be behind that smooth cordgrass in the upland areas. So in high tide, that black needle rush, those roots are going to be submerged in water, but in low tide they're going to be exposed, and so they can kind of dry out a little bit. It's also called black needle rush because the water that travels up the stem is going to be salty, And so the salt isn't always good for plants, and so that salt is going to kill the tip of the plant and turn it black as it travels up that blade of grass. It makes it very, very dry and very, very pointy. So whenever scientists go out there to research stuff in the marsh grass, we have to wear goggles so that we do not get poked in the eye by that black needle rush. That would not be fun. But
Rain is watching too.
Who's that?
Rain.
Hey Rain. There's also some small snails, so like periwinkle snails like to hang out in the marsh grass, and they kind of travel up the blades of the grass and they eat different epiphytes and things that are on the surface of the grass. So an epiphyte is going to be a small microscopic organism that's performing photosynthesis on the surface of a blade of grass or a surface of another organic object. So those periwinkle snails are going to be eating all those off of the surface of the grass, which enables the grass to photosynthesize itself better. So they're actually convenient for them. Just saw an osprey, but I lost him in the fog. Anything? Nope. No luck? Nope.
Maybe next time.
Maybe next time, yeah, that's just kind of how science goes.
It's a few degrees warmer.
You're at the mercy of the world, basically. So whatever nature wants to do, that's what you're doing that day. So if that means it's thunderstorming and there's high seas, then that's what you're dealing with. So it just really depends. Any other questions?
I don't think so. So I guess we'll go ahead and wrap this up. We'll be doing more live videos with these guys. They have so much knowledge. They're so great at what they do and teach just hundreds of children. And so we're gonna definitely do this some more and get them out here showing you guys what we do all the time. If you want to learn more, contact us. You can sign up your students for our Coastal Science Camp, Coastal Explorer. We do all kinds of different stuff. There's a pelican. You can see him a little bit out there before he disappears into the fog. So, thank you guys.
Bye.
And we'll see y'all next time.
Bye.
Bye.